invitation to join us today. Dr. P. Karthikeyan, Professor and Head, Department of Management Studies, Periyar University Center for Postgraduate and Research Studies, Dharmapuri in Tamil Nadu. Dr. Karthikeyan sir is an accomplished individual in the field of research. We are honored to have Dr. Karthikeyan sir have today to share their knowledge and experiences with our faculty members. Dr. Karthikeyan sirs, their educational qualification is MBA, MPhil, and PhD. Sir rendered nearly 16 years of service in the teaching field. His area of specialization is management, marketing, and research methodology. Sir published many papers in national and international levels. Sir is a member of Board of Studies in Vivekananda College of Arts and Science, Tiruchengodu. Sir produced 2 PhD holders and ongoing is 5. Sir is a membership in Professional Society, the Indian Society for Technical Educations. Thank you, sir. Welcome you, sir. So now I hand over to Dr. P. Karthikeyan, sir. Thank you,
Thank
sir. Thank
you,
you, sir.
thank you, uh,
Janardhan.
Janathan,
Yes, sir.
Professor of
Yes.
Commerce Studies, and
Thank you,
Professor
sir.
Sweetie Regina Mary, Madam, for inviting me uh, as one of the resource persons in this 1 week program being organized by the Department of Commerce, Finance, and Accountancy. Uh, I feel very much happy to see that in this vacation, people are very much happy in organizing this kind of program for the benefit of the researchers, and the researchers also uh, happily participating, and the number is good. So, with this small acknowledgement, with the permission of organizers and the participants, um, I start my presentations, and the presentation slide is over with the Sweetie Regina Mary Madam. And please, ma'am, please share my slide
Yes, sir.
pages.
Is it visible, sir? Is it visible, sir?
No, ma'am.
Presenting. Now, sir? Now? Is it visible, sir?
No, ma'am.
Now, sir?
No, it's not coming.
Oh,
Now screen is being shared,
Okay.
not the PPT pages, madam.
Now, sir? No.
No.
Now, sir?
Yeah, now you just click on sampling techniques. It's coming.
Ah,
Click on
okay.
sampling techniques. Yes,
Yes, sir.
yes.
Okay, sir. Is it visible, sir?
No, ma'am.
I clicked
Ah,
that.
ah,
Now, sir?
no,
No.
no.
Okay. Now, sir?
Now it's coming. Now it's
Okay.
coming.
Okay, sir.
Start slideshow, madam.
Okay.
Slideshow.
Okay, sir?
Okay.
Oh.
Okay. Friends, it's a painstaking process taken by the organizer to bring the uh, to sort out the technical issue. So, resume back. Now, I feel very much happy in sharing my thoughts on sampling techniques, which is very basic, and many of you people may practicing knowingly or unknowingly in your studies, research, as well as in your routine life. Actually, in this discussions, I have a plan to split the presentation into two content. One is the sampling concepts, and the second one is sampling techniques. So these two things which we want to discuss before to discuss on about the sampling techniques. It is a mandatory one. We want to swim into the sampling concepts. So, what are the sampling concepts predominantly which we normally use for research work? The first sampling concept is population and sample. So, what is population? I think, friends, am I audible?
Yes, sir.
Yes, randomly, I will check. Amritalingam, sir. Amritalingam, sir, if you are in line, please. Am I audible? Okay. Now move on to next slide. So what is population? What is population? Any idea from the participant side? Actually, population is the entire group that you want to draw conclusions about. Say for example, say for example, suppose we want to study the dietary habits of all high school students in a city. So the population is all high school students in that city. So the target is population. Here, what is sample? A subset of the population selected for study from the population, right, is called a sample. So for example, we might select 200 students from different schools in that city to survey. These 200 students represent the sample. So samples are the representatives of the population. Means what are the features, what are the limitations faced by the population may be reflected through samples. So this is the strength of sample. So that we must understand the importance and significance of sampling. So what is sampling? We got some input about the population. Population is the entire group that you want to draw conclusion about. So sample is a subset of the population selected for study. Okay. So what is sampling? Sampling is the process of drawing sample from the population selected for study. Okay. So next topic is sampling frame. So we got about the population, we got something about the sample, we got something about sampling. Okay, so we may discuss about sampling frame. What is sampling frame? A list or database from which a sample is drawn, or the database which may support the researcher to draw the sample from the population is called sampling frame. Say for example, if we have a list of all high school students in a city from school records, this list serves as the sampling frame. So sampling frame should ideally cover the entire population to avoid bias. To avoid bias. That is most important. So when you're talking about this to avoid bias, what is sampling bias? This is another question that we may ask. So what is sampling bias? Sampling bias occurs when the sample is not representative of the population. So we have to identify the right representative, okay, means right sample. We have to identify the right sample from the population so that we may avoid bias. So this can be due to non-random sampling methods, non-response, or exclusion of certain groups. So these things may sometimes lead to enjoy sampling bias. We should not enjoy sampling bias in doing our research work. Say, for example, if we only survey students from schools known for their athletic programs, our sample might not represent the general high school students' population's dietary habits, leading to sampling bias. Okay, so when we talk on about this sampling bias, we have to discuss on about a margin of error. Margin of error is another one sampling concept which we want to discuss on. So it indicates the range within which the true population parameter is expected to lie based on the sample statistics. Based on the sample statistics. Say for example, if our survey results show that 60% of the students eat breakfast daily, with a margin of error of plus or minus 5%. We can say that between 55% and 65% of all high school students in the city eat breakfast daily. So this is just a generalization that may be applicable. Okay. So the next concept is law of large numbers. Law of large numbers. When we talk on about sampling, we have to look into that concept also. Law of large numbers. What does it mean? As the sample size increases, the sample mean will get closer to the population mean. Okay. So as the sample size increases, the sample mean will get closer to the population mean. So we have to increase the sample size. We have to increase the sample size. We have to concentrate on adding more number of samples to increase the accuracy. Say for example, if we start with a small sample size of 20 students, our sample mean, say for example, average number of fruits eaten might be quite different from the population mean. As we increase our sample size to 200 or 500 students instead of 20 students, the sample mean will coverage to the population mean. So this is the basic idea of increasing the sample size leads, okay, accuracy, covers law of large numbers, sampling concept. The next is sample power. Sample power. What is sample power? Sample power refers to the probability that a test will correctly reject a false null hypothesis. Means we have to reject the null hypothesis, okay, when it is false. We have to accept the null hypothesis when it is true. Otherwise, we have to face type 1 error and type 2 error in accepting and rejecting the null hypothesis. So whatever type of error, then the generalization out of findings will not suit with our population, and the policy making and decision making towards that process, research outcomes, everything will become a meaningless one. So in other words, it is the ability of a test to identify an effect if it actually exists. If it exists. So this is about sample power. So far we discussed about what is population, what is sample, what is sampling, what is sampling frame, okay, what is sampling bias, what is margin of error, okay. These things we discussed along with we discussed about law of large numbers, sample power. So these concepts, sampling concepts we discussed. Then we may get into the next portion in the discussion is sampling techniques. Sampling techniques. So friends, you may be knowing that we have two sampling techniques. One is probability sampling and the second one is non-probability sampling. Friends, what is probability sampling? What is probability sampling? Probability sampling techniques are methods used in statistics to ensure that every member of a population has a known non-zero chance of being selected in a sample. Means every element in the population will be given, every unit of the population will be given equal chance to participate in drawing sample, okay, for our research study. The next type of sampling technique is non-probability sampling. So non-probability sampling techniques are methods where some members of the population have a zero or unknown chance of being selected in the sample. These techniques These techniques are often used when probability sampling is impractical or impossible due to constraints like time, cost, or any other things like accessibility. So these factors may influence the researchers to choose probability rather than non-probability. So now we may discuss about methods of non-probability sampling techniques. Methods of probability sampling techniques. We have five. We have five probability sampling methods. One is simple random sampling. Second, systematic sampling. Third, stratified sampling. Fourth, cluster sampling. Fifth, multi-stage sampling. We'll see one by one. So the first one is with suitable example. Okay, right? So what is simple random sampling? What is simple random sampling? See, uh, every member of the population, every unit of the population, every element of the population has an equal chance of being selected. Okay. Say, for example, imagine you have a jar with 100 marbles. A jar with 100 marbles, each numbered from 1 to 100. Okay. To perform simple random sampling, you could draw 10 marbles out of the jar. Okay. Blindly. Each marble has an equal probability of 1 by 100 of being chosen. Means here in this to perform this simple random sampling method, you may use some other techniques. So you may put lot number system, your lottery method, okay, random number method. Okay, that may help you to do this simple random sampling method in an effective manner. Say, for example, you may create a lot. Okay, you may fold the paper. Okay, every in a box, and you may shake it well, and you may draw 10 seats. Okay, out of hundreds, and that numbered marbles may be taken for the purpose of testing the quality, performance, and other aspects connected to marbles. So that you may finally conclude that marbles available in that jar, okay, remaining 90 also having the same quality and the same features. You may conclude in that manner. So, friends, so simple random sampling method or basic, which we widely use in probability sampling technique. Second is systematic sampling. So, friends, so what is systematic sampling? Members are selected. I mean, samples are selected from the population at regular intervals. Giving regular intervals means we may adopt interval sampling so that systematic sampling method may be achieved in a better way. Say, for example, suppose you have a list of 200 employees, and you want to select a sample of 20 employees out of 200 employees. Your idea is to draw only 20 employees. So in that case, you would divide 200 by 20, 200 by 20 to get an interval of how much? It will be 10. 200 by 20, and the answer is 10. Answer is 10. Okay. So how we may proceed with this systematic sampling? Here, okay, starting from the randomly chosen number between 1 and 10. So here you may use simple random sampling or lottery method or lot method. Okay, you may write again. You may write a number in every lot. Okay, in a sheet you may fold and keep it in a box, and you may shake it well, and you may draw any one out of 10. any one out of 10. That probability number is 5. Okay. So say for example, it is 5. So you then select every 10th employee on the list. Say for example, first sample is 5, serial number 5 or employee code number 5, and the next employee will be, okay, roll number 15. Third sample will be roll number 25, 35. Okay, in that way it will go up to 195. Finally, you will reach 20 samples out of 200. So this is simple sampling method, sorry, systematic sampling method, which is available in the probability. Third is stratified sampling. Friends, so stratified sampling, the Sweetie Regina, madam, anything you want to?
No, sir.
Okay. So the flow is okay,
Yes, sir.
madam?
Yes,
Flow
sir.
is
Yes, sir.
okay? Everything is okay?
Yes, sir. Yes, sir.
Okay,
Yes,
thank you,
sir.
thank you. Okay, the next is stratified sampling. So what is stratified sampling? Friends, the population is divided into subgroups, so-called strata. So-called strata. Based on a specific characteristic, and random samples are taken from each strata. Each strata. So please remember, okay, we have to create strata, so-called subgroups from the population. Okay, so based on specific characteristic and random samples are taken from each strata. Say for example, okay,
Slide
if
down.
you
Now, please see. Please check. Okay, okay, okay.
okay, it's coming.
Uh,
Okay,
thank you.
okay. Say for example, if a school has 1,000 students, um, divide previous one, madam, previous. Yes. If a school has 1,000 students, divide into 4 grades. Okay, you may be a freshman, sophomores, juniors, seniors. In that way, you may create. Okay, and you want a sample of 100 students. Okay, you could randomly select 25 students from each grade. This ensures that each grade is proportionately, okay, represented. Okay, so what are the situations to choose stratified sampling? The first one is geographically dispersed population. Geographically dispersed populations. Second one is large populations. Large populations. Okay, these two situations may force the researchers to choose stratified sampling. Say, for example, if you go for a geographically dispersed population, conducting research in a nationwide survey on household energy usage, you know, so counting the number of households in our nation, that number itself big, and taking sample from that. So large populations, a health survey across all schools in a large city, metropolitan cities like Chennai. So it will be a hectic one. In that case, friends, you may go for using stratified sampling. So you may create subgroups from the population, means you may divide the population into subgroups based on a specific characteristics. Based on specific characteristics. Next is cluster sampling. Friends, what is cluster sampling? The population is divided into clusters. usually based on geographical or administrative boundaries. And entire clusters are randomly selected. Entire clusters are randomly selected. Say, for example, imagine a city divided into 20, imagine a state, not city, divided into 20 districts. And you want to survey households about their recycling habits. You would randomly select 5 districts, so-called clusters, and then survey every household within these 5 districts. Okay, so this is what called cluster sampling. What are the situations to use cluster sampling? Friends, first thing is heterogeneous population with key subgroups, not homogeneous populations, heterogeneous populations. In stratified sampling, homogeneous population will be considered, whereas in cluster sampling, heterogeneous population will lead to create group. Okay, if you construct a subgroup in a population with homogeneous nature called stratified and heterogeneous synthesis cluster sampling, ensuring proportional representation. Ensuring proportional representation is the second situation that may influence you to choose cluster sampling. So what are the key points for choosing between cluster and stratified sampling? When you talk about stratified sampling, use when the population has distinct subgroups, so-called strata, that you need to represent proportionally. Ideal when within stratum homogeneity is high and between stratum heterogeneity is significant. If so, you may choose stratified sampling. When you may go for cluster. Use when population is naturally divided into clusters and it's logically or financially impractical to sample individuals directly from the entire population. So this is ideal when within cluster heterogeneity is high and between cluster homogeneity is assumed. Okay, so please remember heterogeneity and homogeneity or nature of the population. Okay, the group subgroup will lead you to choose cluster or stratified sampling. The next is in probability is multi-stage sampling. So what is multi-stage sampling? Friends, a combination of 2 or more sampling methods. Okay, it typically involves selecting clusters and then performing random sampling within those clusters, so-called multi-stage sampling. Say, for example, using the city example above, state example above, you might first use cluster sampling to select 5 districts from a state. Then within each of those districts, you could use systematic sampling to select 100 households per districts. Or you may use some other probability sampling methods that we discussed so far to select 100 households per district, so-called multi-stage sampling. So I think I made clear on about probability sampling, and we may move to the next part of the sampling techniques is non-probability sampling methods. Friends, here we have 4 methods under non-probability sampling techniques. The first one is convenience sampling. Second, judgmental sampling, also called purposive sampling, quota sampling, snowball sampling. We have 4 things that we have to see. The first one is convenience sampling. So what is convenience sampling? Samples are chosen based on ease of access and proximity to the researcher. So here equal chance will not be given to participate in the sampling. Unlike probability sampling, okay, the researcher make use of this sampling method, okay, to complete their research work. Say, for example, a researcher stands at a mall entrance and surveys the first 100 people who pass by. This sample is convenient because the researcher doesn't need to seek out participants. They come to the researchers. Okay, this is what called convenience sampling. Of course, you can also review about a movie. Okay, you may stand out of stand at exit point of the theater. Okay, and survey the first 100 audience who pass by so that you may rate the movie. So this is on about the convenience sampling, friends. Next is judgmental sampling. Also, we may call it as purposive sampling. The title itself gives you clear cut meaning about the same. Friends, samples are here selected based on the researcher's judgment about which subjects are most useful or representative, okay, from the population. Say, for example, okay, a researcher studying expert opinions on a new educational curriculum might choose to interview only experienced teachers in the field. The researcher uses their judgment to select participants who they believe have the most relevant insights. So this is one of the best example, and recently this topic also in hotline. The next is quota sampling. Quota sampling. Friends, the population is divided into exclusive subgroups called quotas, and subjects are selected non-randomly from each subgroup to meet a predefined quota. Predefined quota. Say, for example, friends, to understand this concept, suppose a researcher wants to study the reading habits of people in a city or town. They decide to survey 50 males and 50 females. The researcher might go to different places like park, library, okay, and other places available in that particular study area, and select people until they meet the quota for each gender. Say for okay, so this is what giving equal importance to all the groups, all the subgroups, okay, created in this case. Maybe male and female is one example. Okay, UG students and PG students is another one example. Okay, arts college students, 50 students, and engineering college students, 50 students is one example. Okay, in that arts college students, 25 male and 25 female. Okay, so in that way you may create quota. Okay, so that your quota sampling method will be achieved successfully. The next sampling method is, friends, snowball sampling. So the existing study subjects recruit future subjects from among their acquaintances. Say, for example, the snowball sampling is one best example that you may say. When you go to the two-wheeler parking, particularly in the cycle parking area, if you push one cycle on another, what will happen? So the entire cycle in that row, cycles in that bicycles in that row may fall down. In that way, it is it is tough, or you may use any other method to catch one particular sample, and with that representation or reference, you may meet another sample. Say for example, okay, in studying a rare disease, a researcher might start with one patient and ask them to refer other patients. Okay, they know who have the same condition. Okay, so they may be in queue, they may wait for doctor's arrival, and they may wait for their token. Okay, they may speak with them, and they may have contact details and everything, so that if you catch one particular rare disease patient, through them you may get another samples. So this is called snowball sampling. So friends, so far we discussed about sampling concepts and sampling techniques. In sampling concepts, we discussed about uh, populations, sampling frame, sampling bias, margin of error, law for large numbers, then sample power, okay, and sampling techniques. In that, we discussed about probability sampling, meaning methods, and non-probability sampling, meaning methods, widely with suitable examples. I hope everyone satisfied with my presentation. And if you have any doubts, please post your doubts. Otherwise, I may say thank you. I think
Participants, if you have any doubts, you can unmute yourself and you can ask questions.
Regina Mary Madam, I satisfied with my delivery.
Yes, sir. Yes, sir. Any
So
questions?
thank you, participants, for your present listening, and thank you, organizers, for your invitation to act as a resource person for this 1 week program. Uh, uh, Thank you, Ambika Devi Madam, for your message. Thank you, every one of you, please.
One second, sir. I call Ms. Rekha Naidu, Assistant Professor, to deliver the vote of thanks.
Thank you, ma'am. First of all, I would like to thank our management for giving me this opportunity to deliver the vote of thanks. On behalf of Shift 2, Department of Commerce and Department of Accounting and Finance, Patrician College of Arts and Science. I would like to thank God for His abundant blessings showered upon us for successful conduct of this event. I would like to extend my gratitude to our Director and Secretary, Brother Naveen Francis, for his support and confidence in permitting us to conduct this event. I thank our keynote speaker, Dr. P. Karthikeyan, Professor and Head, Department of Management Studies, Periyar University, Center for Post and Graduate and Research Studies, who, in spite of his busy schedule, has accepted our proposal to be a resource person for this PDP and enlighten us with his valuable inputs. I also thank our academic director, Dr. Fatima Vasant, our principal, Dr. Geeta Rufus, our vice principal, Dr. Anantapriya Srinivasan, for being constant guiding force in all our endeavors to excel in the field of education. I thank all the professors and research scholars who have registered and are attending this event, and also thank the faculty members of our department participating in the event. Last but not least, my deep sense of thanks and appreciation goes to all the participants who are live with us attending this program with great enthusiasm and has made today's event a great success. Once again, thank you all.